Hello, so this presentation is about factorising polynomials involving complex numbers. By the end of this presentation you should be able to use difference of two squares to factorise quadratics, use completing the square to factorise quadratics, use the sum or difference of two cubes to factorise cubics, and use the factor theorem and long division to factorise cubics. So let's get into it. We get asked to factorise this one, z squared plus 9. Straight away I look at that and I see that as a difference of two cubes, two squares, a squared minus b squared. And you remember a squared minus b squared is a minus b, a plus b. You say, hang on a minute, that says plus 9, how does that get to be a minus? Well, I make that z squared minus 9i squared, which is the same as z squared minus 3i all squared, so it becomes z minus 3i, z plus 3i, and that's factorised. So the critical point, anything which is a plus, you can make into a minus by multiplying by I squared, which is minus 1. Ooh, left off a bracket. Just check that. There's our rule there. Difference of two squares. Okay, now we get a quadratic, z squared plus 6z plus 12. When we're factorising this, there's two ways of going about it. I'm going to use completing the square. So z squared plus 6z plus 12, and we're looking for our values. We look at the coefficient of z. Half of 6 is 3, so plus 3. 3 squared is 9, so plus 9 minus 9. Minus 9 plus 12 gives me plus 3. Then you say, now I'm using difference of two squares. Plus 3 is the same as minus 3i squared. So that becomes z plus 3 minus root 3i, z plus 3 plus root 3i. So remember, we've used our difference of two squares for this last factorisation. Okay. Now this is an interesting one. This is z cubed plus 8. And the key here is for you to recognise that as a difference of two cubes. Now we have a rule for a difference of two cubes, or a sum of two cubes. So we have sum of two cubes, and we say a cubed plus b cubed equals a plus b outside of a squared minus ab plus b squared. And the corollary rule is for the difference of two cubes, and the difference of two cubes says a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. When you look at these two rules, you'll notice there's a pattern. They both follow exactly the same pattern. The only difference is in the placement of the minus sign, the negative sign. With the difference of two cubes, the negative sign is at the front in the first bracket. With the sum of two cubes, the negative sign is in the second bracket. So this is a sum of two cubes. I'm looking at z cubed plus 2 cubed. Z cubed plus 8 is the same as z cubed plus 2 cubed. So I'm just following the pattern. Z plus 2, and then it's going to be z squared plus 2z plus 4. Now that's factorized with a linear factor and a quadratic factor. How do we get from the quadratic factor? We complete the square for the quadratic factor. So z plus 2, and then we're saying, well, that's going to be, I'll just do it all in one step, z plus 1 all squared, so a plus 1 and minus 1 up here, minus 1 plus 3 plus 4 makes plus 3. So that gives me z plus 2, and using my difference of two squares here, that's going to be z plus 1 minus root 3i, z plus 1 plus root 3i. And there are our three factors. Okay, so this one, z to the 6 minus z to the power of 64. We don't know anything about z to the 6, but we do know that z to the 6 is the same as z cubed squared, and that 64 is 8 squared. So that gives me a difference of two squares, z cubed minus 8, z cubed plus 8. What do I see there? Is a difference of two cubes and a sum of two cubes. So that becomes z minus 2 outside of z squared plus 2z plus 4, and z plus 2, the other side, this is a sum of two cubes now, z squared minus 2z plus 4 again. Now, I have two linear factors and two nonlinear. We can make the nonlinear linear by completing the square. And so that's going to become z plus 1 all squared plus 1 minus 1. So that becomes plus 3. This factor is linear. And then I've got z minus 1 all squared plus 1 minus 1 plus 3. And let's use difference of two squares again. So z plus 1 minus root 3i, z plus 1 plus root 3i, z plus 2, z minus 1 minus root 3i, and z minus 1 plus root 3i. And what do you know, we started with z to the 6 and we've ended up with 6 linear factors. I'm taking 840 and I'm saying how many 15s go into 840. So you might remember long division, and the rule for long division is that it's just divide, multiply, subtract, and then bring down, and then we go back and start again. And it's just a continuous cycle of divide, multiply, subtract, and bring down. So the question is, how many 15s go into 840? I don't know exactly, but I really want to know how many 15s. So my how many question is how many 15s go into 84? How many 15s go into 84? And the answer is 5. So 5 goes on my top line. Then my multiplier is, well, what is 5 times 15? Well, the answer, that's 75. So I've done my multiply, now I subtract. Pardon me. So I subtract 75, and that gives me 9. 84 takes 75. Then the last step is to bring down. I bring down the 90, and then I go back and start the whole process again. This time I say, how many? My how many question is how many 15s go into 90? And the answer is 6. So 6 goes on the top line. 6 times 15 is 90. I subtract, and I'm left with a remainder. This is what we call the remainder of 0. So the answer is, how many 15s go into 840? 15 with remainder 0. Now we're going to use that process when we're dealing with cubic polynomials. And this all relies on what we call the factor theorem. And the factor theorem says, if the polynomial of a equals 0, then z minus a is a factor. So I'm looking for a number that I can substitute in to this equation, this polynomial, that will give me 0. Now the number that I'm going to substitute in today is 2. So I'm substituting in 2 cubed minus 8 times 2 squared plus 25 times 2 minus 26. And what do you know? I substitute that in. That gives me 8 minus 32 plus 50 minus 26 gives me 0. So that tells me that z minus 2 is a factor. Now this first number that we substitute in, it's a little bit of guess and check, but the reality is it has to be, the number that we substitute has to be a factor of the final, of the constant. So you don't just randomly substitute. We'd normally start with 1 or minus 1, then we'd go with 2 or minus 2, and if we have to go any higher than that, we know that it's going to be a factor of the constant. Now let's do our long division. We're asking ourselves, how many times does z minus 2 go into z cubed minus 8z squared plus 25z minus 26? Well, we just do the same process as before. Divide. How many z's go into z cubed? And the answer is z squared. Then we say, well, that becomes our multiplier. It's divide, multiply, subtract, and bring down. So we're going to multiply z squared. So the first question I asked was, how many z's go into z cubed? And the answer was z squared. Then I say, well, z squared times our factor z minus 2, which gives me z cubed minus 2z squared. Z cubed minus, go away, 2z squared. And now we subtract. Z cubed minus z cubed gives me 0, minus 8, minus 2. So that becomes plus 2 I get minus 6z squared. Now I bring down plus 25z. And I start the process again. How many z's go into minus 6z squared? Minus 6z. Minus 6z becomes my multiplier, so minus 6. So I'm multiplying this. Minus 6z times z makes minus 6z squared. Minus times a minus makes plus 12z. And now we subtract. The first two cancel out. 25 minus 12z gives me 13z. Bring down the minus 26. How many z's go into 13z? The answer is 13. 13 times z, we multiply out here again. 13z minus 26. And we end up with a remainder of 0. So that's telling me that my factors are z minus 2 and whatever we got here for our answer, z squared minus 6z plus 13. Now that's a quadratic, so we want to make linear factors. How do we get linear factors? Our linear factors are going to by completing the square. Z minus 2, and that becomes z minus 3 all squared plus 9 minus 9 becomes plus 4. So z minus 2, z minus 3 plus 2i. Sorry, I just did the plus. And z minus 3 minus 2i. So a difference of 2 squares for that one. Okay, and we've got 3 linear factors. So by the end of this video, you should have seen how to use the difference of 2 squares to factorise quadratics, use completing the square to factorise quadratics, use the sum or difference of 2 cubes to factorise quadratics, and use factor theorem and long division to factorise cubics. And you might need a bit of practice at long division, but it's one of those things that will work for you when it gets there. And